Now let us look at case 6. So case 6 is a pulley system, a single pulley what? System. That's what we have in what? In case 6. It's a single what? Pulley what? System, which is comprised of two masses. Let us look at what they have in case 6. We have a pulley, single pulley system like this. And in this pulley, we have the tension from the pulley, which is carrying the mass. Two masses. And it's come like this. The second one, mass is this. So this is the shrink. It's going up like this. Yes. And the mass, here, let me call it what? Mass M1. Here we have M what? M2. There is a tension on what? On this. This is what? Tension T. Let me put what? The tension here is this. Tension here is this. But in this structure, note that what? There is a particular what? Weight of this mass is W. Weight 1. The weight of this one also acting downwards with 2. Here will be what? M2, M1G. The weight of this one. The weight of this two will be what? M2G. The weight of the two bodies, they are acting downward. But you will observe that what? In this place, here, this body is moving what? Upward. It's moving what? Up, like this. This is direction of acceleration. The body, when we get to this side, the body is what? Is moving what? Is moving down. This is what? Acceleration. But in this diagram, the note mass M2 is greater than what? Mass what? M1. So for this kind of the what? Of the single pulley system, how are we going to what? To determine the acceleration and the tension on the what? On the rope. So the first thing that you will say was, for mass M what? M1. If you look at M1, the object is what? Is moving up. Moving what? Up. Or moving upward. So if you want to determine for this mass F1, you will need to what? To redraw the diagram. If by redrawing it like this is M1, this is the tension on the rope, this is the tension on the what? On the rope, and the weight of the block is what? Is acting what? Downward. And the weight is what? W1 M1 G. Here we have mass what? M1. This place we have tension T. And don't forget that what? The body is moving what? Up. Acceleration. For mass what? For moving forward. For this now, we have two forces that is acted on mass M1, tension and what? And weight. So here, the body is moving up. The tension is more than weight. So from there now, our resultant force, our what? Resultant what? Resultant force so our resultant what? Resultant force there, it will be tension minus what? Weight 1. Because it's moving up. Tension is more than what? Weight. You will now have what? This resultant force is what? M what? M1A. And tension T minus weight. Change the weight to the M what? Mg2. M1G. Have you now? If you rewrite this equation, you will have M1A what? T minus M1G. This is what we call what? Equation 1. Equation what? Equation 1. We are done for what? Mass what? M1. So the next thing that we now do is what? Set for mass M what? M2. Which is what? Moving what? Down. Object. The object is moving down here. Since the object is moving down here, we will draw the diagram. We have this, and the weight of this is acting downward, W2, which is M2G. And the tension is acting what? Up. So the weight W2 M2G, which is M what? M2. Here we have tension. But don't forget that what? The body is moving what? Down. When the body is moving down, this by acceleration A. It will tell you that what? Here, body is moving up. Tension is more than weight. Body is moving down. The weight here more than what? Tension. So you will now have what? Resultant force should be weight 2 minus tension. Because weight is more than tension here. Resultant force is what? M2A and what? M2G minus T. This is what we call what? Equation what? Equation 2. The next thing that we do now here is what? That's what? Combine equation 1 and 2 together. By combining 1 and 2 together, we are going to have what is equation 1? We have M1 A T minus M1G. This is equation 2. M2 A Mg2G minus what? T. Don't forget that what? This is what? Equation 1. This is what? Equation 2. The next thing that we do now is what? We will add what? Equation 1 and what? 2 together. Here, add equation 1 and 2 together by solving it simultaneously. So the process of adding, t will cancel t here, and here we have what? m1a plus m2a equal to the what? Here we are adding m2g minus m1g. By doing this, what is common factor here? A out, you have m1 plus m2 equal to the what? G common here too. You can equal to the what? m2 minus m1 into bracket g. So here you can now have what? A should be what? m2 minus m1 everything bracket g over what? m1 plus m2. So this is what? The acceleration of a suspended mass in a single pulley system. So let us solve this question together. Solution. As a light insensible strength passes over a smooth pulley and carry mass of 6 kg and 12 kg at the end of the masses are released from. Let's calculate. For this, let me draw the what? The pulley system. This is the pull, and we have what? Mass. This is my first mass. This is the second what? Mass. This is what? We have tension here. We have tension here. So from this, we know that what? This one is what? 12 kg. Here we have 6 kg. Tension T, tension T. So the acceleration, this one will be moving what? Along this direction. This will be what? Moving along what? This direction. So we are asked to find the what? The tension. Let us apply our formula. What is, you can still do it normally. There's no need for you to memorize the formula. Note that what? Tension is more than weight here. Have you? So, yeah, for 6 kg, say what? For mass 6 what? Kg. For mass 6 kg, what are we going to have? We have resultant force should be T minus what? Weight 1. So the resultant force will be what? Resultant force will be M1A T minus what? If we apply this formula straight, we get the answer. Or should we apply this formula? They are spending for me to what? To derive the formula again. So it's the same procedure. We are asked to find what? For this, if you want to, it's normal that no need for you to memorize this formula. Don't follow this what? These steps. You get this. So we are asked to find the what? Their common acceleration. Have you? Can say what? So yeah, A, to determine as a what? Acceleration. So please, for the convenience sake, there is no time to what? To waste. So what formula of acceleration? A equal to what? M2 minus m1 d over what? m1 plus what? m2. What is m1 given? 12 minus 6 multiplied by 10. 12 plus 6. We have a should be equal to the what? Wow. 6. 6 times 10. We have 60. Then 12 plus 6. To give us what? 18. Are we? 18 is 60. So we have 3.6. So the acceleration here will be equal to the what? 3.6 meter per second. So A equal to what? 3.6 meter per second. That's the acceleration. What is the second one? B. To determine the what? Velocity. So we use what? Equation of what? Of motion. V equal to the what? U plus AT. And it's from what? At rest. At rest means what? U equal to what? 0. You now have what? V should be equal to what? 0 plus what is acceleration? 3.6. I didn't give her the time. Yes. 5. Multiplied by what? 5 seconds. 4. That will be what? 20. Velocity will be what? Will be 20 meter per what? Per second. Per seconds. The last one is what? To determine the what? The speed. C. To determine the distance. Determine distance traveled. Call it what? X. Using third equation of motion, S equal to the what? Ut plus half of AT square. S is this. What is U? At rest is 0. We have half of what? AT. What is my A? A is 3.6. What is time? Time given is what? Is 5. 5 square. So 5 square is 25. So now what? X should be what? 0.5 or equal to the what? Half of what? 3.6 times 20 what? 25. So let me press the calculator. We have 45 meter. That is the what? Distance. So now I will give you what? One question under this single pulley system to solve for me. And you're able to put the answer on the comment section. So we now move to the what? Case what? Case 7. Let me give you the questions now to solve. I will write it here. So this example 2, I will not solve it. Just follow this same procedure I apply in the first example here to solve it. And put your answer on the comment section. So I will read it. I will tell you whether you get it or what or not. So let us move to the what? To the next case, which is what? Case 7.